how does it work?
Yeah, so
Magic.
you're gonna be number 5. So we have a few intro slides, and then we'll just call everybody up one by one, and we'll have your 4 minutes. The microphone's there. Yep. And then there's a timer in the data tracker, so there'll be a 4-minute timer that you'll be able to see with your slides on this monitor, so you can keep yourself in time.
So I get the clicker?
Yeah, either you can give it to me and say next slide, or you can take the clicker and just go through the slides.
And you just got just 4 minutes.
Come here.
The rules are you just have 4 minutes. Use them wonderfully.
I'll do my best. So what are you going to do? You kick me away?
Oh, you don't want to ask. We have a button.
There's a trap door?
Yeah.
A big thing falls down on your head from the top.
But you only have that. I saw on the agenda. 10, 12?
12, actually.
12?
We have 12 now. Yeah.
Sometimes.
So yeah, it probably won't take the whole time, but
Okay. So a few seconds enough, you know.
Oh, no, you don't want to risk it.
Sure.
When do you decide to start?
Actually, a couple minutes after. It's 6:01. A couple people just dropped in.
Yeah, a few more people come. I guess they don't really need to hear us talking.
Originally, we had the welcome reception scheduled here. We like to have it close by so that people can just come, but we had to swap it with the hackathon.
It's okay. So, I reckon we should start. Does this microphone work? Have we been everybody hearing what we're saying anyway? So that's
Yes.
all right. So it's like Liz and Gory doing the chat here. So this is going to be a little bit more informal from the front, but we're going to be very formal on the agenda. It's the IETF Hot RFC. It's brought to you by Liz and Gory. That's me. I've not done this before, but this lady has. I pretty much know the format though, so please keep to the rules. Rule number 1, we have a note well and a note really well. These are the IETF note wells. If you're new to the IETF, these are really important things to read quickly so that you understand our rules of operation. We really do need to obey the note wells. They govern where the IPR sits in the IETF, and without these, we would be in a big mess. So this is important. Have a quick look at it. It's not changed much over the years, and it's easy to read. We have some meeting tips. Do I have to do all the talking? You want to do some talking? I do all the talking. Okay. Well, we have meeting tips. Here we go. I will get told if I do it wrong. In-person participants, make sure to sign to the session using MeTechUp. This applies to all sessions. It helps us collect the statistics for who's in the room, which is important for the group, so we don't get scheduled into a small cupboard because the group only records 4 people present. Therefore, the wonderful secretariat think we can fit in a room with 4 people. So make sure you register. It also tracks who's present in case there's any issues or anything else comes up. Use the MeTechUp Lite client. That's the one that's easy and simple to use because it doesn't involve the video session. You can use that on your phone or personal device. If you want to ask questions, join the mic queue, but we don't have any questions here. So you can join the mic queue, but we won't let you talk. I thought I'd tell you in advance because it wouldn't be so exciting to join the mic queue here. In other IETF sessions, all the ones that follow, joining the mic queue gives you the chance to stand at the front when the chair lets you and talk. So you get a chance to reach a mic and say something. Remotely or on site. Remember, we have remote participants, and remote participants participate equally in the IETF. So please be sure to do the right things to let the remote participants join and use it. If you're participating remotely to this session, Remember that if you're going to talk, which you won't do because there are no questions, so why have we got that last bullet? Use a headset. If you were going to ask questions, which you're not allowed to, so we'll experiment with that later.
We do have one remote presenter, so there will be one person who will be presenting.
Oh, yes. Well, the remote presenter, of course, is very welcome, and that wasn't meant to mean anything about the person presenting remotely. Phew. If any of the presenters have problems, let us know. We are friendly people and we'd love to help you. Hot RFC is about how you make a request for a conversation. It's a play on the RFC word, but the whole RFC thing is better actually written as request for a conversation. It's about getting people to talk about the issues which are important to you and hopefully to collaborate to write document. Each person in this session gets exactly 4 minutes. If you want more, you're not going to get them. So at the end, we will put the slide, please applaud, and it will be wonderful. It will look like this. Yeah, exactly. We don't do questions here. If you have any trouble with delivery or really anything that's important, just let us know. We'll do our best to help. So you can follow along. We're using a data tracker for all slides, so you should be able to find the slide sets and follow those on your computer if you wish to. We will hopefully finish a little bit early, so the conversations will start as soon as we are finished. I hope you enjoy the sessions. And the first slides will be by this person. Yes, if you wish. Would you like a clicker? Or would you like?
So thank you for the opportunity to provide an update on IPv6 traffic percentage and also the packet loss rate. I gave a similar talk in the previous IETF in which we reported 2 problems. Next page, please. The first problem is that the IPv6 traffic percentage seemed to be lower than it should, while the packet loss rate seemed to be higher than it should. And after we gave such a talk, we received a lot of input. And I really want to thank the people listed here, and some of them may not be listed here. And after that, with this input, we learned a lot of new things. I don't have the time to report all the new things that we learned, but I want to report a few important ones. I think that the most notable is that we now define a new concept, a new KPI called IPv6 usability. And it's defined as the traffic percentage divided by the product of user percentage and content percentage. And I think that it may be difficult for you to get immediately, but the idea is like this. If IPv6 is equally usable then as IPv4, then this percentage will come out as 100%. But if this, this number higher than 100%, it means that, IPv6 is more usable than IPv4. And if it's less than 100%, then it's less usable. And with this, and the data that we can find on the internet will calculate the IPv6 usability from just one single company perspective. I think that's the first caveat. And also, for the world, for 12 countries in 6 continents. So for each continent, we pick 2 countries. And the result is like this. In short, basically in North America, IPv6 seems to be more usable, and also Oceania. But in Europe, Asia, and Latin America, IPv6 seems to be a little less usable. As a result, over the world, it will be 90%, so slightly less usable. And on the IPv6 packet loss rate, we narrow the range down to maybe 0.5 to 0.6%. Next page, please. So these are some other important findings that we have is that we learned that the fixed CPE's IPv6 requirement is a little bit dated. So V6op is going to update RFC 7084. We are also going to write a BCP for IPv6 deployment in enterprise. So we very much, welcome your contribution. Another interesting thing that we learned is that in the vertical industry, people are far from using IPv6. For example, in the railway industry, there are so many, applications and devices that are not IPv6 capable. So again, these are some of the interesting things that we learn. Next page, please. So what we are looking for is, like, first we look for your feedback, whether you agree with this formula. We believe that this is a very, a single number that can kind of like measure, kind of like compare IPv6 to IPv4. So we feel that, it's very interesting. We want IPv6 traffic stats from operator and enterprise. We want people to measure the IPv6 packet loss rate in various scenarios with us. And we want also people to co-author, draft, and then also to investigate this, how to convert the register IPv4 with us. Thank you.
Just a quick note from the front. I can see lots of chairs available at the front. If you're stood at the back and need a chair, just come forward while we're getting the next speaker up. You want a clicker?
Yeah, do you want to, you can take the clicker or you can just say next slide, however you
You
want.
heard me, I think. Yeah.
I can.
Yeah, okay.
I have two slides.
Okay.
And so let's go. So I am Emil from Orange, and it's my son from Cisco. And so in 2022, Orange and Cisco experimented you can go to the first. Experimented, you see the reduction of power, what we name a smart power delivery, on Orange Velodrome in Marseille. And the use case is to be able, you see, to cut the power of Wi-Fi access point. And there are many in the stadium. There are something like a bit more than 1,000. And so to make it short, they make the adaptation of the control plane to be able to switch PoE energy in the switches. And the estimation shows that we can easily save 20% of the energy consumption of the stadium. But it's
Thank you, Emil. Yeah, thanks to Emil, he has introduced one of the use cases for energy management, right? How to reduce power consumption. But there are other use cases that can be enlarged to the concept of sustainability. And what we understand for sustainability is basically to preserve the resources that we have. And looking into this for some time now, there are a few challenges that we want to introduce as well as part of the draft that we have been working on for the last few months. We have been just submitting, but it's including some concept like a circular economy. Circular economy is not only reusing, recycling, but also looking at the material, at the primary materials that the hardware components are built, as well as packaging, transport, things that are important to consider within the data to make better decisions when you are going to optimize those resources. Normalization is another aspect that we are looking in, and normalization based on the different sources that we have. Data sources are coming from different angles, not only from the ICT, but as well as we have to calculate CO2 emissions, and this is one of the goals of sustainability. And this is coming with a factor that we are applying to the energy consumption, right? Depends on the location. And this needs to be normalized just to compare same things. Optimization is something that Orange has been experienced with the energy management exercise that it has been done, and the optimization on the resources, just reducing the energy. And this is coming more and more important even with the introduction of AI and ML. Accuracy and granularity, big topic, right? We need to be precise on the measurements that we are obtaining from networking in the sector that we are, and as well cross-domain. We have to be context aware. we are comparing different domains. We are comparing collaboration with other verticals like a data center, and we have to be looking at that data. With this, I want to make a call to the importance of the information that we are measuring. At the end, we are going to get a lot of insight and wisdom that we have to apply to the data that we are managing. And based on this, we have been creating a few drafts. I invite you to read through them, and we invite you for the side meeting tomorrow. It's at 8:45 in the Carling room. Many thanks.
Don't forget tomorrow morning.
Next we have Nicola.
All right, so this is Nicola from the Science Association, and I would like to give you a quick overview of what is going on with Science at this IETF. So just a bit of background and motivation. You probably have heard about it, but if not, Science is an interdomain internet architecture, and we believe it can provide, it can fill some gaps in area, especially of interdomain, path-aware networking, trust-enhanced networking, and so on. And this is an architecture that is really deployed, so there is some deployment experience, especially in Switzerland, in the finance industry, now a bit more in healthcare and so on. We have multiple implementation, and that's why we believe Science can get better with community feedback. So that's why we have spent the last year to document how Science works and how the protocol works in existing deployments. So here you can see the drafts. And I think what is really, what we would really like to appreciate feedback on really finding a space for this work in the IETF. Science is quite cross-domain. And so that's why we have a few activities going on. So we have been at the hackathon, and we have already been working on a deployment guide on some applications. So if you're interested to know what we've been doing, then show up at the Hack Demo Happy Hour tomorrow. And then there will be a bigger discussion about the topic I mentioned before, like where does this work fit best at Banerjee. So that will be tomorrow at 1. Besides discussing some of the drafts that you have seen before, there will also be some deployment experience from Anapaya, a Science vendor. There will be also some user experience from a representative of the finance network that is productive today. And then we'll take on to discuss the next steps. Besides that, we also quickly mention Science at the path validation site meeting that will happen on Tuesday. And I think with that, I conclude. So we hope to receive more comments and reviews on the drafts that we have today. And we hope to have some support in trying to find this work a proper space within the IETF. Thank you.
Thank you.
Okay, next up we have Kihan.
We can do it if you want. We do it. No problem.
Hi everyone, I'm Kehan from China Mobile, and today I'll show you some our viewpoint on collective communication, use cases, problems, and requirements. Next slide, please. What's collective communication? It is an inter-process communication model, a logical communication model that plays a key role in high-performance computing and modern distributed AI training workloads. And there is a phenomenal trend that these applications are becoming converged in today's data center networking. And also collective communications contain a lot of communication pattern like many-to-one and one-to-many and many-to-many workloads. But currently, these implementation of this different collective communication model is realized by the underlying network is implemented in point-to-point mode. And here are some typical applications deployed in today's data center, like this distributed AI model training and big data analysis, and also distributed storage. So next slide, please. So we have found that the major problems, and here to implement the major problems on why the current implementation of collective communication is not so performant, because the point-to-point implementation of these collectives incurs much overhead, reflect in three different perspectives. One is it will occupy large bandwidth because there are a lot of duplication in the packets transmitted on the delay, and also it will introduce lots of data movement, and also it will inevitably introduce large number of data copies at endpoints. So there will be a very obvious communication bottleneck and performance degradation. So if you want to design performant networking, find a better solution, you need to save bandwidth. And because it's really, especially for bandwidth sensitive applications like distributed AI, the bandwidth is the new oil. I like the metaverse. It's not from me, but I think it's quite impressive. And also, you need to reduce data movement and decrease data copies. So this leads to a solution called collective communication, collective operation offloading, and it's very related to a term like in-network computing. So next slide, please. So here you can see that the communication pattern. We have showed the problems and the requirements in our drafts that submitted to TSV working group. And if you are interested, you can see more details in the drafts. So in the draft, we have listed three major design issues, from transport issues like end-to-end reliability, to implement multi-point to one-point of these collectives, and also some semantic gap and different optimization for the blocking and non-blocking transmission mode. And also it has some relationship with the one-to group IP multicast, and also they have some relations with the management and controls. Next slide, please. And here are some message for you guys to get more information of the topic. We will hold a related side meeting on November 9th on Thursday. If you're interested, you're very welcome to join us and give your valuable feedback. So we are looking forward for collaborators to seek for potential standardization opportunity of the work in IETF. So welcome more discussion and contribution. Thank you.
So just a note from the front, I see the first 4 rows of chairs have quite a few seats vacant, and I see a lot of people standing at the back. Please do come forward if you wish to, because there are plenty of seats in the first 4 rows.
Hello, everyone.
Would you like the clicker?
Yes, I do like the clicker. Thank you very much.
That doesn't take your time.
Hello, everyone. I'd like to share some of our work. This is in staging right now. It will be in production next year. I want to tell you about the emergence of the universal name system. Yes, it's yet another name system. Please suspend your disbelief. And also a universal certificate authority. And what we mean by those two things is that we're talking about a name system at the individual entity level, and we're talking about a fully automated cryptographic infrastructure for each one of these entities. You can think about contrast it with the current DNS and certificate authorities. So the UNS and the UCA are entity-centric. The entities have an independent existence. All the cryptographic security is built in, not bolted on. All of it is automated and generated. There is no human administrators inside the information space. And it finally makes the concept of global zero trust across domain possible. This was not possible a few years ago. This is in fact enabled by confidential computing, also known as trusted execution environments. Here are the 3 key properties to make this possible. The fact that the data is protected in use so that you can actually manage keys within those environments. the fact that you can remotely verify those things through the attestation process, and the fact that those chips have these verifiable sources of entropy that enables you to do decentralized cryptography in a remotely verifiable way. And so our goal, of course, is to fix the fundamental weaknesses of today's domain-centric architecture, where you can't get rid of the privileged insiders. Everything is supposed to be administered by people. How do you remove them from the equation? And the second thing is that URIs are strings. You can't do cryptographic linking or chaining or binding with it. So we are left with associations of data with URIs that is at the goodwill of whoever programmed the server on the other side. And so this is reflected from Alice and Bob's perspective in today's world. They are just resources within domains. And there is no zero trust from this perspective. They have to have blind faith in everything that sits in the middle. It's reflected in the structure of URLs, where everything is under the authority of the domain name and the domain administrators. So in this infrastructure, everything is in fact anchored in what we call STEM IDs, which are random identifiers, one unique random identifier per entity. And then the association of data is done through the generation of the derivation of keys through an HMAC function and encryption of data with that resulting key. All of this unites all data and identifiers in a mathematically unbreakable way. The architecture looks something like this. I'm going to speed up a little bit, but essentially the entities connect to an agent. The agents get verified by the UNS and the UCA. And the interesting reflection here is that if you do have a shared parent between attestation layers, you actually have a path to automate key exchanges. And that's what enables automated end-to-end cryptography between any two entities. The concept is fully recursive, hierarchical, so you can layer it up, you can scale it out, and you can now stitch chains between individual entities at global scale, with chaining entities, not blocks. It looks pretty like this. When you fold it, you see that there's no human in the middle. You just have an automated infrastructure that automates all key exchanges. So we're here to present and discuss this work. We want to figure out where in the IETF it should go. We also want to start a coalition for global and neutral governance, and we'll have a side meeting tomorrow at 2 p.m. Thank you.
Thank you.
Next up, Roland.
Just one slide. Hi, I'm Roland. I want to bring Kira to your attention, which is a scalable zero-touch routing. I already talked a little bit about how it works at IETF118 in London last year. Basically, scalable, what means scalable here? I'm talking about 100,000 of nodes in a single domain, but could be even more. It is zero-touch, which means doesn't require any configuration and adapts after that while running. The goal is basically to provide a resilient autonomous control plane connectivity. So I guess that operators would love it because you can't break your control plane by any misconfiguration. We have already running code in a very early version which provides zero-touch IPv6 connectivity. There's the first internet draft, which is not yet complete, but will be updated after the IETF meeting. And basically, when I'm here, I want to standardize it. So we have many practical options to choose from. And so I think I need the broader IETF expertise in order to get it right. So there are some more presentations about Kira in the routing area working group on Tuesday. And also, I guess I will fall off the agenda, but still I'm on the agenda in the NMRG on Friday. And if you want to know more about Kira or discuss use cases, collaboration, and maybe also next steps towards standardization, there's a side meeting that I scheduled right after the plenary on Wednesday, and afterwards we can have dinner. And that's basically it. If you want to know more.
Okay, next up, Hannes. Do you want to drive your own slides? Okay.
Okay. Does this work? Okay, cool. Hi, everyone. I don't think I need to mention here in this audience that IoT hasn't been blessed with security. And we in this organization and also in related organizations have been working on many different profiles, extensions, algorithms to change that. And I think over the last 10 years, we have been quite successful collectively. And if you take any of the IoT devices from regular manufacturers, they will just run public key crypto fine, meaning elliptic curve crypto. So that's a good thing. Then we also advanced the state of the art even more by optimizing essentially the heck out of it. You see some numbers here. We managed to shrink down the size of a key exchange to pretty much nothing, right? So, and there's more data available in those charts for other configurations which are even smaller. So it's impressive, and that works well and is needed on some of these low power networks like LoRaWAN. But there's also a sort of the dark clouds showing up on the horizon when all these post-quantum crypto algorithms came along. And if you look at the performance data of them, like it's scary. It's huge. And it's many times the size of the bytes that I've shown you previously, just with one public key, not talking about the chain of keys and some of the other constructions that we are talking about. On top of that, there's also a lot of uncertainty, specifically when we talk about IoT devices that are supposed to be out in the field for 10, 15, 20 years. And so the whole transition story is difficult, operational aspects, etc., etc. So what are we supposed to do? And I think that's where some of the community, and I worked in that community for a long time, are a little bit puzzled about on what are the implications of all of this going forward. Are we supposed to sort of switch the paradigm, switch to maybe symmetric keys in a Kerberos type of style? Are we going to transition in the midterm to maybe away from these constrained devices and change the network to something more powerful, and so on? So many possible ideas, and I'm here to basically reach out to you to ask you, like, what are your views? And if you are working in the space and interested to share your thoughts, come over to me and we talk, and maybe we have some good ideas on what we could do. And this is my email address. Thank you. Because I still have 1 minute left, I can also do another talk.
Well, he
And I'm
also
not
has
kidding. No, it's actually another topic. Totally separate topic. Revocation. So also a topic that is not necessarily new. Lot has been said about certificate revocation, meaning X509 certificate revocation already. And here's a small list of specifications that I'm sure you're well familiar with. And there's also some proprietary stuff from Mozilla and Google. And these things are deployed with some success. And there's always the debate on whether we should reduce the lifetime of certificates to avoid having these long-lived certificates that require more sort of revocation information to be sent around. And if you, like me, work in an adjacent group, namely in the OAuth community with identity management on the web, you will have seen that we worked on these JSON web tokens, which are, in a nutshell, kind of documents just signed. But over the years, we have extended them to also include public keys, which turns them into certificates. OAuth itself is kind of a protocol for maintaining and refreshing those JSON web tokens when they're used as access tokens. So that's not a big issue in terms of revocation. However, there's some new work also being discussed this work in the SpiceWAF, where people want to use these JSON web tokens as verifiable credentials, which turns them into long-term certificates, essentially just in a different format. And the same has been done also for another format but based on CBOR, and the links below. So you choose your format, but it's essentially we're having some parity between X509 certificates, JSON Web Tokens, and CBOR Web Tokens. Lots of references. So there's some new work happening in the OAS working group that we just recently adopted, and I happen to be the co-chair of that group, which is why I'm mentioning this now. And this new revocation mechanism specifically targets the previously mentioned these JSON Web Tokens. And it mimics academic work that was published called Let's Revoke, which at that time was focused on X509 certificates, and also work in the W3C on the same topic. And so there's some new work coming along. I will skip that slide, what exactly the details are of those status lists. You can look it up if you care. But the question to you is, if you are security minded, you might be interested. You might want to learn more about this technology. Do you find it useful? Is it maybe also applicable to X509 certificates? If it's useful for JSON Web Tokens, maybe it actually is. Or is there actually room for improvement to shrink down these revocation lists to make them more scalable and more privacy friendly in general? And so if you have some ideas, come to the OAuth working group meeting, because we're going to discuss this and there will be this new work happening. Thank you.
Okay, next, Joe.
Thank you. Good evening. I'm here to talk to you about MTL mode. What is MTL mode? Well, it's a method for reducing the post-quantum signature size impact on expanding message series. So when you have multiple messages coming along, you can sign an overarching thing once and use the authentication paths to verify those messages independently, so that you reduce the amount of time you have to spend and the size you have to spend on those post-quantum signatures. Now, there's concepts in here about a ladder and a rung so that it can evolve as you add more. You don't have to redo it all for the older messages, and it lets you continue along with the series at a high level. So what are the benefits? Well, the main benefit, so that I can keep moving quickly here, the main benefit is that it allows you to shorten the signatures and use constructs that are already available today. Like hashes are already available in a lot of places and they're already fairly efficient. So you can reduce that overall impact of the new algorithms on the series. We introduced a draft at IETF117 to introduce the concepts of MTL mode. And really what I'm here to talk to you today is last week we open sourced a reference implementation library that implements that. And so it gives you a way to go ahead and do some experimentation or use it without having to go through the whole MTL mode draft and implement it. Just for our no obligation, there is some IPR declarations. You can read the text around that. All right, and finally, please take a look at the open source library. Please take a look at the draft. We'd really love to get feedback around that. Specifically, you can see the URL on here for the repo. And specifically, we'd like to know things like what language bindings should we have, what crypto libraries would it be good to initially align to make it so that people can actually experiment with this, use it well, and give us good feedback. Thank you. Thank you.
Next, we have our remote presenter, Adrian. So,
I hope you can hear me.
We can hear you.
Good. Next slide, please. The internet is increasingly mediated by platforms and now proprietary AI. A personal digital agent protocol could be intentionally designed to reverse this trend. It would be interoperable across vendors and service providers. It would not lock you into any particular hosting mechanism. And the policies that the agent automated would be portable, again, to avoid lock-in. So this would make it compatible with both swarm and federated personal AI in the future. Next slide, please. So the foundational principle here was actually brought to my attention by an IETF research group on freedom of association and assembly as a universal human right. And so in effect, we're promoting unionization or organization of individuals to face the asymmetry of the large platform providers. Next slide, please. I won't dwell on this. There are many examples now of regulatory responses and government level responses in India to this platform dominance problem. Next slide, please. So this personal digital agent would have to be independent of jurisdictions or federations. It should be able to be community hosted because self-hosting is difficult or impractical still, semi-autonomous, intelligent, and most of all, it needs to be accepted by most service providers and resource servers in order for it to be impactful. Next slide, please. So its scope starts with, in effect, a gift to this principle, which is IETF GNAP, which is in last call these days, and which is a delegated authorization protocol. We would also consider the standardization of the tokens, service endpoints to address the agent, and whether or not the policy management description and interface needs to be part of the scope. Next slide, please. So one diagram. In thin lines below, we have what's already being done by the IETF grant negotiation and authorization protocol, which is basically a successor to OAuth by many of the people who contributed to OAuth over the years. And on top, we have the potential additions that would be needed in terms of making this an alternative to centralized platforms. Next slide, please. So the steps towards this, this kind of work has been going on for quite a while in both on top of OAuth and now what I mentioned with GNAP. We have verifiable credentials to work with this, and we are now starting this personal agent list with a goal of establishing a standard work group. Next slide, please. So please join the mail list or contact me directly. Thank you.
Okay, thank you, Adrian. Next. You want to drive your own slides?
Hi, everyone. Damn, there's a lot of people there. Because I was there in the front row, I couldn't see how. Okay, so my name is Jean-François. I manage an organization called the IO Foundation, and I'm trying to figure out a place for some research we've been doing in the past years, and we kind of suspect the IETF could be that place, but I would like your opinion and possibly some feedback from you. So the idea that we had back in the days was to ensure that technology doesn't do certain things by design. It's kind of a very aspirational idea. But if you think about it, so every single product that you acquire, that you use in a minimally regulated industry will have two sides to it. One of them is going to be compliance, and the other one is value proposition. And in those industries, no one is competing at the compliance level because that's the bare minimum for you to be in that industry. Whereas that's not what's happening in the software industry. There's no such thing as verifying compliance of GDPR, for instance. There's no standard way to do it. And that can be applied for a number of things. And so what was basically inspiring us was this joke that I read many, many years ago, and I still think it's more nerdy joke ever. And it's true. So you would, as us building technology, we are the ones who can control what that technology can and cannot do. The problem is at the moment we don't have the language to define exactly what that is. And so the idea was precisely because so none of us right now, unless there's some hidden architect around here, gets to care about why this building is not collapsing in our heads. We just take it for granted. And you would hope that the final user of any particular digital product also doesn't have to be concerning themselves how it is built. The reality right now is that they need to know way too much. It's a very interesting cognitive dissonance that we have in the industry. And so, slide. So examples about problems that we have right now. So data protection laws are a mess. It's great that they exist, but you don't have an actual SDK, for instance, to be able to implement them. It's even worse when you have cross-border exchanges where ideally you would like to have the situation where you send some data between borders and you can add a manifesto indicating what you want to happen to the data and what you don't want to be happening to the data. That's not possible at the moment. And the next step would be to be able to do remote attestation to verify whether those requirements in the manifesto have been or not observed. You know, we hear a lot of conversation and a lot of concern about, oh my God, AI is going to kill people, it's going to do these bad things and bad, you know, whatever. Sure. Can you please define me what that means? How I'm going to be testing algorithmically that it happens or not? We don't have that at the moment. And think about neural implants that are coming up. Neuralink has been approved by the FDA for human testing. It's great that we will be able to allow people to walk again. I don't think it's so great that it will be possible to inject images into cortex. And again, we don't have the possibility to verify that those things happen or not happen. So part of the things that we would like to do in this research group, if it ever makes sense for us to have it over here, we'll be looking into some data modeling that have to do with digital twins and so forth. We see the importance of some taxonomies, which specifically those related to what would be the processes that you don't want to happen upon data for those negative outcomes. And one very interesting one on data use case scenarios, which we haven't found anywhere. So the asks is going to be for you, if you know if this has been attempted before, what worked, what didn't work, potential collaborators, subject experts, and detractors. That always helps a lot. You can find me around. That's my email. That's also my V card. And so, thank you.
Great, and last but not least, our last presenter, Jan-Fred.
Would you like to be in control? Yeah. Okay. I hope so.
Okay, thank you. Yeah, welcome. My name is Jan-Fred. I'm with the DFN, the German Research and Education Network, and we are one of the national roaming operators for EduRoam. So we are in charge of EduRoam in Germany. And before I was working at the DFN, I was at the University of Bremen, and I was administrating the EduRoam there. And from that, I have a lot of experience with EduRoam and the problems that especially end users get into. So together with some colleagues in the EduRoam Europe steering group, we want to propose a new EAP method based on FIDO keys. When we don't want to do something new, we need to ask ourselves why. Well, EduRoam configuration is really not trivial. There are a lot of configuration options that you need to trust the user to get right in order to get a secure EduRoam connection. And certificate checks are hard, and there is, in the current interface at least, no implicit way to derive, for example, the expected certificate name based on the information that the user is expected to get right. For example, if I have an account for DFN, then at dfn.de. Bootstrapping in bring your own device environments is also a very big problem. So what are the new requirements for this method? Well, we want to have a trivial configuration. We can expect the user to know that their realm is dfn.de, but that's all they should input. So we don't want to rely on users to securely configure things. And the second thing is we want to move away from passwords. Authentication through knowledge is fine, but revealing that knowledge in the process is a bad idea, because we have to trust the whole transport way that no one loses this password. How do we solve this now? Well, we use asymmetric crypto and we use FIDO keys. A lot of devices already carry FIDO compatible software tokens. I can use FIDO with my Android device. Yeah, and there is the possibility to use hardware tokens. We have a way to provision these FIDO keys, for example, via WebAuthn. So we have a simple web portal where users can register their keys, and then on the device they just select, okay, I want to use eduroam with FIDO and my realm is dfn.de. And the device already knows, okay, now I expect a TLS certificate for dfn.de, and the user does not need to configure any security parameters, because if we use WebPKI for WebAuthn, then we can use WebPKI for the EAP authentication. So what now? Well, we have an early draft. There are still a lot of to-dos in there. We have a site meeting on Monday, so tomorrow at 6 p.m. in Carlin 4. And we are looking for feedback on the design. If there are some people that operate EAP servers, please share your experiences. If there are people that know FIDO very well and immediately say, well, there's a red flag, please come talk to us. So we will present this in the EMU session, and yeah, just find me or my colleague Stefan Winter in the hallway for discussions. Thank you.
Well, that's all, folks, but thank you ever so much for coming. Lots of people. And thanks, of course, to all our presenters for the wonderful presentations. Okay. So how does the timer button work? You just pressed it and it kind of
Yes, oh, I just closed out
know
of
you
it. But
closed it,
so
sorry.
in the Medico on the bottom, there's like 3 buttons for an extra menu with a couple of extra options. And
Yeah.
there's a timer option in that menu. And then it just, you fill in how many minutes or seconds or whatever, and you click start timer, and it just automatically goes.
And you can do it again if you get it wrong. Well, it's already running for you.
Yeah. Okay. You just go back into the timer menu the same way, and you can cancel it early.
Yep. Okay.
Yeah.
Oh, well.
It's very helpful since they added that. We started with Spencer sort of like trying to do a separate timer app, you know, on the phone or something.
And it's so
much easier to
it's good.
Here in the
Yeah.
So, thank you very much.
So is Spencer planning to come again in future? Is it
I think so.
just
yeah.
a blip?
I think he just wasn't able to travel.
Yeah, well, that's fine. Good.
I'm sure if you'd want to help out with this again, I'm sure you could put it up.
Yeah, I'm sure I could fill it. If I'm here, I can. Hey, Loana.
Hi.
You didn't do it at all. You can still do one. No, I thought that might be the reaction.
Yeah. What are you doing now?
What?
What are you doing? What are you going to do?
No.
Yeah.
I actually have no plan. I was wondering where to put my remains of my food. Then I was going to go. That was it, basically.